Alright, let's make a spindle. Let's make this as painless as possible. I have a model here, DMU85. We want to capture this area of the spindle here so we can bring it back into the tool database and leverage that as part of an NC tool assembly so we get all the benefits of collision avoidance at the tool path level. So I'm going to go ahead and start hiding a bunch of this extraneous stuff that we don't care about. Get rid of all this. We're really just focused on the lower portion of the spindle here. Alright, we got it down to pretty much what we're interested in. Now, spindles in the hyperMILL database, they have to be a revolved piece of geometry. So despite the fact the column on this machine is a square, we're going to end up with a circle of this diameter. So there's some considerations there. Obviously, if we revolve this, depending on which pieces of geometry we get, we could end up with something bigger than this or smaller than this. Now, the sort of school of thought here is it doesn't really matter. Having something captured here is way better than not having anything captured, because we're not going to get any collision avoidance at the toolpath level when it comes to the spindle assembly here in the column if we don't have it attached to an NC tool. We're going to get all the warnings in simulation, but nothing at the generation level. Now, we could grab just the nose here, and that might be enough for some people, especially on some other machines like the Doosan's have a particularly long like spindle nose snout. That might, be plenty for you to clear your table. Because the one on this machine is really short, it makes the most sense to capture the entire thing in this case and use it. Now, there is something here. I've almost whacked these coolant nozzles before, so I'm going to go ahead and set a new work plane there. I'm just using some hotkeys on my keyboard. And let's go ahead and grab this here and kind of extend these surfaces out a bit so that it better represents kind of like the safe area, and that looks pretty good. So now when I look at the front of the spindle here, that'll work much better. Now let's grab our work plane here and just get it clear away from the part, and we can grab all this solid and we can use the shape contour feature. Now I believe this, I don't use these too often, is somewhere up in is it under the shape function or the curve shape contour. So we're going to shape contour, we're going to choose the entity we want to project it onto, and that's right up here. We'll click OK. We can go ahead and hide all that now, and hyperMILL is going to want just half of the profile, and it needs to be open and it needs to be on center of the work plane here, if that all makes sense. So we can just grab the line tool here, and we'll just extend this out both ways. Use our trim tool, get rid of this excess geometry here. What trim tool did I grab? Alright, so this is what we're looking for. Okay, and now the easiest way to do it, I'm sorry I got some of this stuff on another screen here, is here in HyperCAD S. You can do it in the tool database if you want to use like the point line function where you just enter numbers in there for, the spindle goes over 10 millimeters and then up 5. It's super time consuming and it's a little confusing because despite the fact you're building out a partial profile, it wants the full diameter value. So the first time I modeled this up, I actually did use that feature because I was kind of oblivious to the fact that I could grab some simple geometry. And the first time I mounted it, I'm like, what the heck? The spindle's like exactly half the size it should be. Oh gosh. Even though we're just doing a revolved profile, it's looking for the entire diameter. When we use the geometry here, it's a non-issue. So I already tested this out, as you can see over here, but we can start fresh. It doesn't really matter what we do. We just want to grab this and bring it back in the tool database. And the easiest way is with building a new tool, whatever we want. We don't care. We're going to come right up here to the spindle area. We're going to pick this, and then right here we have the option to select geometry from CAD. Now we can come in here, we'll grab this, and look at that, we have our profile. Now if for some reason it comes in backwards or upside down, you can use the tool here. This is akin to what the format looks like inside the tool database if you were to manually enter everything in there. It's a nightmare. And we can click OK, and look at that, we have a spun profile now of our spindle. Now there's one more step. We have to take this and export it. Now this exports it to whatever database you're connected to. So we could double check if we come over here to our hyperMILL utility settings, and in the database tool there's the wizard. Now you could use your wizard if you're not already connected to your database to quickly select where you have your database located. And then in theory here, if we export to database, we'll just give this some random number. Successfully finish import, and then sure enough, if we open up the tool database, we see that tool that we exported, which we don't really care about, but more importantly, over here in the spindles tab, look at that, we have our spindle now. So we could come in here, DMU 85, we'll call this complete. Like I said, it might be beneficial for us just to have the nose if we were to have a collision with the larger part of the column, which maybe was bigger than the physical machine because of how we revolved it or something. It might not actually, it's unlikely, but it gives us options. Now we'll see this coupling feature again. If you just have one or two machines, this isn't going to be super critical, but if we choose our adapter and we choose our HSK63, then theoretically when we're back in our NC tool, just like when we define our shank properly, we go to select a holder, when we go to select a spindle, we're only going to see machines with compatible connections for our tool. So now when we put this assembly together, we're not just getting collision avoidance at the tool and holder level, it's going to include this whole column, which is going to be wicked important, especially when we're working at like past 90 degrees on the machine. If we're working at 110 or 120, we're hitting those big negatives. This is super helpful. Also people with big machines. I have big machines and I work on small parts, so it's not often that I would ever have a tool holder assembly where the spindle would actually clear the table. Usually I'm having to put my part quite far off the table or high on the table, so when I'm tilted, it's sticking out really far so I can get the entire spindle column down in front of the table. This gives me another tool to kind of help get that good tool path on the first shot, instead of hopping back and forth between simulation and toolpath generation to find that sweet spot where everything clears. If you have any questions, my details are down in the description. Feel free to get a hold of me. I'm happy to share with you anything I know.